the stream. Awesome! It is coming through and we are live. So, welcome everyone to this week's Dev Deep Dives. As a note, before we get started, we'll be distributing a poem, very cute poem in my opinion, by the end of the call. So, be prepared for that. This will happen in the Discord server. So, to anyone watching on Twitter or YouTube, you'll have a chance to do this after we say the instructions. But you need to join the Discord server. You can find a link to it in our Collab.Land Twitter's link tree. That's in our bio on Twitter. But we'll guide you through it when the POAP is available. So no worries about it. And yeah, welcome everyone on Discord. I see some new faces in the audience, so welcome. So glad to have you here. And welcome, Raymond. I am very excited about this dev deep dive. We can get started whenever you're ready.
Sure. Yeah. So welcome back to the new year, and we're gonna kick off the session with an exciting topic. Especially, we have been busy building Telefriends, which is a social fiber we created and launched recently. I want to share a little bit more insights, like how we build a technical stack so that we can have this hybrid approach that allow some of the activities happen on chain and some of the activities happen off chain, and how we meaningfully service the UI UX with the different data in the state, and how we meaningfully connect the dots between the two. So give a little bit context. I believe some of you already saw the demo or the Telefriends mini app we have. And just for the completeness of this talk, to set up a little bit context, like say on Telegram, if you search for the Telefriends bar, and you can have a DM with a bar, that's where everything starts. Then the very first thing is you can launch the app itself. So it's a Telegram web application called TWA. So if you click on that, then you start to see the UI. And some of the pages are really relevant to today's discussion, because to build this UI and especially allow the users to buy and sell passes, we need to handle the different data points. For example, we have this dashboard for the global trades, the trending trades, top passes, and you can click on any of the users to go into the user's profile. So say I try to go into this user profile, then we can have relevant information about the user. Then, of course, if you like this user, you want to buy a pass from this user, you can click on buy. And if you have existing passes you want to sell, you can sell here, right? So this bot-driven application has quite a bit requirement on the data set. That's why I want to share more information today. So with that brief context, kind of going back to the technical side, so really we can give you a high-level view, like what data are relevant to this application. So of course, we're doing on-chain transactions, right? So we have a smart contract, and the smart contract maintains certain state. Especially, we try to give a picture, say, hey, first of all, we have this concept of the subject, which is whoever sells the passes, right? And whoever buys the pass, that becomes a holder. So we maintain a couple mappings and the data structure for the Solidity smart contract, so we can really have this one single smart contract that handles multiple subjects and multiple holders. So the most important one is called the subject to the holder balance mapping. So it's a two-tier mapping. The first key is the subject account address, and the second key is the holder's smart account address. Then, of course, the balance is how many passes this holder actually has for that given subject. Then for each subject, we also maintain other states, such as, hey, what's the current supply That's basically the number of passes being sold up to this point. Then we also have each value being accumulated onto each of the subject. So we have this mapping from the subject to the total token value locked for that given subject. We also provide a little bit of enumeration to simplify some of the queries for the smart contract. So we have a collection of subjects, so we know how many subjects we have on the smart contract and what are the wallet addresses for each of the subjects, and we can use the subject address to do other lookup. So I will share a little bit more details about that data structure. But then on the other hand, when the transaction goes on, basically like people buy passes, sell passes, we are emitting a trade event. So what's interesting for blockchain development is the storage space is quite constrained, right? And you want to minimize the on-chain state as much as possible. But on the other hand, you have ongoing activities, and you don't want to lose that information. For example, these trade events are really, really critical because without this event, we cannot meaningfully create this different dashboard to understand the transaction history, or like understand how many people are buying somebody else's pass and what's a cumulative summary or value for a given a subject. Right? So we kind of use this hybrid approach. Like on one hand, we maintain critical state in the smart contract itself. On the other hand, we emit these trade events, and these trade events will somewhat index, so we have that visibility to understand the ongoing transactions. Beyond the on-chain state and the on-chain events, we also deal with some off-chain state. So as a Telegram user, right, you don't have to bring your MetaMask wallet. So the assumption is as long as you log in with Telegram and potentially enforced by the passkey, you establish your identity with the Telegram application itself. Then we provision an MPC signer for you on behalf of the user. Then you have the signing capability without, managing the private key. And then in reality, we or anybody else don't even have access to the private key. But it's a signer that's capable of sign on behalf of the Telegram user and perform on-chain transactions such as buy passes or sell passes. Then from the signer, we also create a so-called like smart account on a given blockchain. In our case, the production mainnet we use is Arbitrum1. So every single user, you will get a smart account on Arbitrum1. And that smart account is a contract-based wallet that's capable of doing transactions, which include buy passes or sell passes. So that's another interesting off-chain state. And of course, we value your engagement. Not only we want to have some metrics to help us improve the product, but more importantly, we need to get credits to whoever participate, right? So in the past, for decentralized apps, it's a little bit difficult to give the quantified attributions or credits or points to the different personas. So in the Telegram case, for example, as a potential creator, you might share invitation links so that your future members can join the ecosystem by clicking that link. And when the member clicks the invitation link, that creates acceptance of the invitation, right? And there are also a lot of other meaningful events, such as you buy a pass, you sell the pass, or you create a private group, or you actually become a Telegram Pro. So we care about this different, engagement, and we want to formally recognize this engagement as a contribution in terms of points. So points is a simple way to really capture your contribution to the ecosystem, right? So we are exploring different ways to do that. So of course we can do that in a centralized database, but that's not Web3 about, right? So we want to progressively become decentralized. So we want to even push the boundary for the data ownership, so the data will be independent of Collab.Land internal system and have that visibility and the discoverability, and then potentially that different kind of attestations, the user actually owns that and can share with other parties as well. So based upon this understanding and driven by the UI UX, we create a technical stack to support that, which could be interesting for similar use cases. So that's hopping into that. So we look at a few different tiers to handle the data story. So the first one, obviously, it's the Solidity smart contracts. So we have a bunch of smart contracts to handle the Telefan's transactions. And as I mentioned early on, we already defined some mappings and other data structure as a storage layout to keep track of the different engagement and the transaction behaviors. So that happens in the Solidity smart contract. And meanwhile, we also take the future upgrade of the smart contract into consideration. So we adopt a proxy pattern so that the storage layout expected by the proxy and by future implementations will always have that consistent view, so that whenever we upgrade the smart contract in the future, it keeps the current state as is without messing that up, and have the ability to add new functionality to the smart contract over time. So I will show a little bit of storage layout later on, but then on the other hand, we mentioned we have these meaningful treat events coming from the Telegram smart contract to surface the events in such a easy to query way. We actually adopt the graph protocol and create a subgraph for the Telegram smart contract. So we kind of organize the information in such a way, not only just the raw events. And in the raw events, we have information like who's the subject, who's the pass holder, and what's the amount of the transaction, is that buy or sell, and some timestamp associated with that. So that maybe 7 to 8 different attributes in that event. But to build a UI UX for Telegram, we need to organize these different events in different dimensions. For example, you want to index by the subject. You might want to index by the user itself, right? And you might want to aggregate some information so you can give stats out of the box all the time. So that's the responsibility of the subgraph, which lays on the smart contract events and have a mapping to index such data with different entities into a database and surface that through a GraphQL API, so that we can meaningfully use the GraphQL API to get the data in different formats, in different expectations to support our UI UX. So that's a second technical stack we built. Then we get deeper into the off-chain space. On-chain, we pretty much know what are the well-known paths to get this data available and visible. But for off-chain, it's a little bit wide west, right? So the different approach to do so. On the naive side, we can pretty much do everything in our centralized database. So we can keep track of everything. And that serves the purpose for the functional perspective. And if the user trusts us and our centralized system will stay open all the time, then that's a good solution. But we really want to push the boundary a little bit and see what's the public visibility we can achieve, and what's the interoperability for the different credits or points we collect and measure for the given user into some standard, into some decentralized storage system. So that's why we kind of explore this Ethereum attestation service which has both on-chain and off-chain support that gives people different type of attestations. And attestation is more like a statement or like a, and that statement is coming from the attester. In this case, could be Collab.Land, because Collab.Land kind of witness your engagement, right? Then these attestations could be independently verified because it's signed by Collab.Land, right? Now, for the on-chain storage of these different attestations, it has the pro and the cons. So the pro side is definitely it's the ease of use, and especially it's very easy to discover the different events. But the downside is there's a heavy cost associated with storing every single point into on-chain state. That will become a financial burden for everybody. Okay, so that's why we say, okay, what's a possibility we offload some of the data off-chain and still have a similar quality of service for this off-chain data? So that's why we turn into some solutions like decentralized database, such as ComposeDB, right? So ComposeDB is built on top of the Swarmic protocol, and on top of that, there's a database indexing capability, so that we can doing a similar way as how we transform the on-chain events into a subgraph. So the ComposeDB allows us to index the different kind of off-chain events into a meaningful high view of these different attestations, and give us the query capabilities through the GraphQL as well. So those are the 4 different tiers we try to use to support the on-chain and off-chain data for Telefrance. So I want to provide a little bit more details for each of the items. So I'm going to switch window a little bit. So the first one is I want to share a little bit the state we have or for the contracts. So I have this Telefrance storage Solidity source code. And if you look at here, we have a bunch of mappings. For example, the first mapping is from the subject to the pass balance of the holder. So it's a 2-level of mapping. So the first key, this is a subject, which is the creator's smart account address. And the second address is the holder's smart account address. Then this one is the number of shares that holder actually has from the creator. Then we have an enumeration of subjects, so we can understand how many subjects are there in the ecosystem. Then we have some other mappings, such as say, okay, for a given creator, how many Ethereum value are being locked onto that bonding curve. And we also track all this information. Another important one is we map from the subject to the supply. Basically, the total number of passes being sold so far. Right? So those are critical information we have as a on-chain storage. Then from the smart contract perspective, this different information will be surfaced from the smart contract. And this is the RB scan, which is Option 1 Blockchain Explorer. And if you go to the contract tab and you click on the read as proxy, so this gives you some view methods that you can see some of the information for this given smart account, right? For this given contract, for example, we can get the total number of subjects here, and we can, get information about the subject index. For example, let's say what's the second subject in the system, and we get this address back. Then let's say we copy this subject, then we can get other information such as, okay, for that given subject, what's the supply there? Let's say put a subject address here, right? Then you can query this, and okay, this one, so 15 passes altogether. So that's the current balance for that given subject, right? Then if you say, okay, let's check who owns that, passes, and then we give the subject name, then we have to get the holder's name, right? So the smart contract basically exposes view methods to share the state, and that's a critical part of the backend system. The second one I want to mention is the events we talk about. So if you click on this events tab, so as any transaction going on, you will see trade events being emitted. So the trade event captures some critical information such as, okay, who's the current user's smart account address and what creators the smart account address they're buying or selling. Then if it's a sell or buy, then what's the amount of passes being exchanged and what's the total value for. Then this one gives you the latest supply of the the subject itself. So these events are the critical events, and that's where we need to this subgraph concept. So that provides a good segue into the subgraph. So we use Alchemy subgraph to do that, and let me go there real quick. So Alchemy subgraph is basically just a hosted service for the graph protocol, and we utilize this infrastructure to maintain the subgraph coming from the trade events. Then we can go to this playground, which is a GraphQL UI. Then from this UI example, we can get a summary of the trading activities, and you can actually get other information such as you can do trade entities. So basically that describes all the trades, right? So we can have ID, yeah, trader, subject, and buy, yeah, share amount, and of course the trader it's an object, so you need to have the wallet address, and you also have wallet address, and you can actually this is being denormalized, so you can get more information about the user. For example, you can get even get balances, and you can have subject, you can have balance here, and subject, of course, you have to get the wallet address as well, right? So this gives you a way to look up the events for the different trade entities and say, okay, this trade happened between this user with this wallet address, and then buy a pass from this subject, and the amount of purchase is one share. Okay, so the subgraph gives us this capability to index the on-chain events and then transform a very user-friendly GraphQL interface, and of course not just for this UI, but also happening at the API level. And again, like a lot of pages from this Telephant's UI is actually coming from the subgraph to give us that kind of data. So those are the data coming from here. Right. So that's a subgraph, and I also want to show a little bit subgraph. Let's see. So the subgraph, it's an interesting protocol we use. Let me go to the subgraph itself and show a little bit of information there as well. Go to that. So in the subgraph, there are a couple of things. Like first of all, we kind of have this manifest for the subgraph and say, okay, we want to watch for this network called Offchain 1, and we also particularly care about this contract address. Then from that contract address, we say, okay, we care about this particular event called trade events. Then we have a function in the mapping.ts that handles the transformation of that event. That points to mapping.ts. Right? So pretty much all the logic happening in this assembly script called mapping.ts. And in the mapping.ts, we have a couple of methods, and the entry point is called handle tree because that's what being defined in the manifest, right? Then from here, it becomes very much like the ORM, like say, okay, let's create a trade entity for all the information. Then we populate the trade entity. Then just not just saying the trade event itself as a plain entity, we're also doing some other indexing. For example, we're doing the user indexing, like say who's the trader and who's the subject. So we organize this information against different personas. And meanwhile, we also doing the aggregation. And what's interesting is in the subgraph mapping, you can call the smart contract to give some information. For example, you can get additional information that's not directly available from the events. So you can even call the view methods from the smart contract to get additional data. For example, in this case, it's a buy price. Right? Then you can do aggregation. You can creating additional records. So just think about you have a database behind you, and you basically use the trade events as a social choose, and you create different records into the database representing different views how the graph should representing. Now automatically this database data will surface as the GraphQL query, right? Then we also have a method to handle the summary. So that's the first GraphQL we run. And say, okay, let's create a specialized record called telephone summary. And the telephone summary basically accumulate the different stats. And whenever the trade happens, like say, okay, what's the number of trades? What are the number of buys? What are the number of sells? How many subjects are there? How many traders are there? What's the total value? What's the total protocol fee, subject fee? Okay. And another thing I want to show is like this so-called like a GraphQL entity. So this defines the schema for the different database records that we're creating. So we have the summary, we have the tree, we have the balance, we have the user entity. So it's very much this relational design that just take the on-chain events and argument that with some of the smart contract calls. Then we basically writing different database records representing different views to make it easy for the UI UX to consume. So that's a subgraph concept we have. So we pretty much cover on-chain up to this point. So let's kind of go back to off-chain, right? So for off-chain, we already talked about the onboarding system we have, which is when you log in as a Telegram user, and we are going to deterministically understand what's the NPC signer address you will get. So you don't even have to do anything. Whenever you log in with Telegram and enforce the security with passkey, you already get a signer, and the signer address is being calculated up front. Then with the signer address, we create a smart account, and the user signer as the owner to start with. That also counterfactually give us the smart account address. So in a way, you don't even have to do anything. We don't even have to do anything. You already have a smart account address. And that smart account address is already capable of receiving tokens or native funds directly. And then later on, you can claim it. So you can claim the signer, you can claim the smart account, then the smart contract-based wallet will be deployed there. So everything is kind of automatically happening when you use a Telefence, but there's a little bit heavy infrastructure behind that to make it possible. Then for the engagement side, we use a queuing system that allows different events to be emit into the queue. Then we have this so-called like a job runners to pick up the request from the queue and doing different things. So to support this off-chain state or off-chain events, we turn into two things. In the past, we already have support for verifiable credentials. And to some extent, you can just assume the Ethereum attestation service is a simplified version of the verifiable credentials. And it has the ability to store that kind of attestation on-chain and off-chain and make it possible to independently verify the authenticity of the attestation itself. So going to the Ethereum attestation service a little bit, this is an open source infrastructure for different attesters to put information on-chain, off-chain. So there's two critical information we care. The first one is called the schema. So remember when we look at the subgraph, right? We kind of, so all the way from the smart contract. So from the smart contract, we define that data structure for the event. Maybe I didn't show that, but let me show that real quick. So we have this type event, and we have this interface. Yeah, so basically, from solidity perspective, when we define event, we kind of define this event structure, which contains a different attribute and what attribute will be indexed. Then going back to the Ethereum attestation, it's a similar concept. You need to define the schema as a constraint. So we define a couple of schemas, such as somebody creates an invitation, somebody accepts the invitation, and then potentially this vocabulary can be extended as we capture more meaningful events, such as you are doing some, trading, or you achieve certain milestone. So every single credit or point will have a meaningful representation of that based upon the schema. The schema defines, okay, for example, when you accept an invitation, what's the invitation ID, who invites you, and who's the invitee, and what campaign is that, and what time you accept it. So this becomes kind of like a on-chain attestation for that schema itself, right? So you can get more information about the schema, and we already have 22 attestations happening on this schema. So you can click on here. So we create some test attestations here, and some of them is kind of like on-chain. Right? So this says, okay, we have this invitation code, and this creator invites a member. This is a member, and this is coming from Telegram, and this is the timestamp that happens. Now, of course, you can point to the on-chain transaction where we submit the attestation to Offchain 1, right? So this is really for the on-chain side, and we can look into this transaction a little bit, right? And this transaction actually handles a bunch of attestations in batch to save the cost. But as you can tell, like we are doing like about 40 items in the batch, so it still costs quite a bit. So that's why, like you say, on-chain is great, especially for the attestation itself. It has this very nice UI and the different tools to like not only see the different kind of attestations, but also has the ability to share the attestation for independent verification as well. So what's the most easy way or most scalable way so that we can potentially push some of the heavy load off chain, but we still maintain that integrity between on-chain and off-chain? So that's where we kind of turn into the Compose DB. Right? So Compose DB is another open source solution coming from Stramic. So Compose DB depends on Stramic. So Stramic, think about Stramic as a data blockchain on top of IPFS. Then Compose DB adding this indexing capability, similar as what Subgraph can do for the on-chain events. So we build an integration with the Compose DB and start to surface that through Compose DB. Then I want to give a little bit of information about that Compose DB usage. Right? So basically, I have this test application. Say, okay, First of all, let's generate some invitations, and from these invitations, we can create different events that we can utilize this service to create different attestations against ComposeDB. And if you get into this detail a little bit, then we say, okay, let's first do an off-chain attestation using the ES service. And what really it does is actually sign the message, right? So Collab.Land signs the message using the schema so that we know this is an authentic attestation from Collab.Land. Then we call this API to talk to ComposeDB and save this entry into ComposeDB. And of course, the ComposeDB itself has the, like the composite that maps the event. So basically, we are sending an event to Swarmic, and the ComposeDB watch for that event and doing indexing for that event and the surface that through the GraphQL API call. So that's why we have these different GraphQL API calls we can make to query the attestation from ComposeDB itself. I was able to run a demo early on, but I have a little bit issue with the local development environment. So I will try it later. But trust me, say we get a similar UI as the subgraph. Then from the subgraph, you can query these different attestations, and that's where we will further integrate with Telefans to give this leaderboard view for the different engagement points in the near future as well. So I talked quite a bit, and it's pretty technical heavy, but the main idea is to support a decentralized app such as Telefans, how we can utilize different technical stack to achieve the data storage on different format, different quality of service, and also try to connect the data points from on-chain and off-chain, and have a meaningful divide of responsibility between on-chain and off-chain. And then toward the end, it's really the availability of the data and also the ownership of the data. And of course, the data has to be visible to the authorized scopes, and there should be a possible way to share the data by the owner and have the recipient of the data owner be able to independently verify the authenticity of the data. So that's pretty much the data story we try to build for Telefans. It's still very early, but we see this nice composition from a couple of technical stacks to support our UI UX, as well as the data ownership, decentralization, visibility, the possible to verify, to give these meaningful points or credits in the Web3 context. So that's very much I want to share today. And I want to give a little bit of time for folks to see if there's any questions or any ideas.
Yeah, thank you so much, Raymond. Maybe if anyone has any questions, you can drop them in the stage chat, or you can also raise your hand. If you prefer talking, you can come up in the stage and ask your question. I know that it may be a bit difficult if we're not developers or all that technical, but for the same reason, maybe you have any questions about the presentation, please don't be shy to ask anything. I'm sure that Raymond will gladly assist you and answer to any doubts that you may have. So please feel free to share those. And in the meantime, I think that it's maybe time to distribute the POAP too. I see someone typing in the chat. I just now came. Welcome, Vinod. It's so good to have you here. And no worries. Also for anyone on Twitter, if you're watching these and have any questions, I'm sure that you can join later on the Discord server, type your question, tag Raymond, and he'll get back to you. if you have any questions. You can also ask them later, or if anyone's watching this recording in the future, no worries about that. But yeah, thank you so much, Raymond. It's pretty cool to see, especially if you've already given a try to tell friends, how all of the background works and where everything is stored. So yeah, even if I don't understand everything, it's still pretty cool to see. So thank you. And let's get to the POAP. What do you think?
Good idea.
Let's go. Okay, so for you guys in the audience, we have a very cute POAP for today. And in order to claim it, you all need to use the / command called POAP claim. So in the chat, write down / POAP claim. And today's claim phrase is Onchain, with no spaces in between. Onchain, or no symbols or anything, all lowercase. And once that you write it down, hit enter, and you'll get a code to claim your POAP. Yes, Vinod, you heard right. Onchain is the secret phrase to claim today's POAP. Again, this is done in the Discord, in our server. So if you're watching on Twitter or YouTube, you need to join our Discord server in order to claim this POAP. So you can find a link to join the server in our link tree. So if you go to Collab.Land's Twitter account, you'll find a link to it. You can follow and join. Please let us know in the chat if it worked for you. Oh, this is actually my first 2024 POAP. How cute is that? I love this. Have you guys already claimed the POAP on 2024? I'm curious to know. I repeat it one more time just in case. To claim today's POAP, use / POAP claim, and the claim phrase is Onchain. No spaces in between. That would be ONCHAIN. Onchain. If you need a code, or if anyone's having any issues with claiming, you can tag me and let me know, and I'll send you a code privately so that you can claim. No worries about it. Also, if anyone's watching on Twitter, you can let Candy know, or send a DM to the Collab.Land account if you need a link. We can also do that if you'd like to claim today's POAP. Yeah, having said that, I believe that we don't have any questions as of now. I'm waiting to see if everyone was able to claim the POAP. But other than that, I think that we are ready to wrap things up. I see a comment from Crypto Portfolio. Claim first one this year, and it's the best one so far. Indeed, yes. Same here. Thank you. I will take it as a compliment. Yeah. Love it. But yeah, I think that we're good to wrap things up. I'd like to thank you again, Raymond, for being here and for presenting today. It's always really great to have you here. So thank you so much for joining and for all of the incredible job that you do. And if you guys haven't tried Telefriends yet, please give it a try. I need to buy your passes, especially yours. So please give it a try and let me know. You can send me or send anyone in here an invite link to your group if you have one, or to your profile, so that we can check it out and buy your passes, because I would really love to do that. Oh, and lastly, oh yes, thank you, Raymond. You can find a link to tell friends in the stay chat right now if you'd like to get started. And lastly, I would like to invite you all to our Collab community spaces tomorrow at 1:30 p.m. Eastern. We'll be talking about the new year, and yeah, I think things happening and predictions for the new year. So it's going to be pretty casual, but I would love to see you guys in there. And also, if you'd like to join as a speaker, please let us know. We would love to have you there as well. Talk with us about anything. So please do let us know, and we hope to see you guys in there. All right. Well, let's end this deep dive in here. Thank you all so much for joining. Also, anyone on Twitter and YouTube watching, thank you so much, guys, and we'll see you all next time. Bye now.